All right, today we're going to go ahead and move into section 6.2. So for today we'll be looking at arcs and chords and solving for different pieces of them. All right, so let's go ahead and get started here. Arcs and chords from a circle. The first term we're going to talk about is a central angle. All right, a central angle is an angle whose vertex is by the center of the circle. So it's an angle that forms by the center of the circle. All right, an arc is the second term, and that's the part of the circle that consists of the two endpoints and the points between it. All right, so the arc is the curling part of the circle. So for example, let's go ahead and draw this into our picture. Let's go ahead and connect a line, a radius here and a radius there. So remember, if it goes from a center to an end, those are technically both our radius. All right, the way this works is the angle that forms between those two radius is our central angle. So the red piece is our central angle in this picture. It's the angle that takes place by the center, hence the name central angle. Now, the arc is the curl between the two radius. So this curl right here is the arc of our circle, the arc that we're looking at. All right, now there's a couple key things that we need to keep in mind. First off, the whole circle is 360 degrees inside a circle or around a circle. Okay, 360 degrees. That means that if we drew in a diameter, and remember a diameter cuts the circle in half, if we drew in a diameter and it goes through the center of the circle, remember that would split it into half a circle. So that arc, this half of the circle, if I took 360 and cut it in half, I know that half a circle is going to have to equal 180 degrees. All right, so a central angle is the angle that forms in the center between two radii or radius. The arc is the arc of the circle that contains all the points between the two endpoints where the radius touches. All right, so let's go ahead and look at a couple of things. The way this works is that the central angle is going to be found by finding what the arc is. So if this arc covers from here to here, x would be the same as whatever that arc is. Or vice versa, the arc will be the same as whatever x is. All right, so that's a case where if they asked us to find this orange arc, we would just copy whatever x is. A minor arc is always going to be less than 180. So a minor arc is less than 180. A major arc is when we're going to find part of the circle that's bigger than half a circle. So it's bigger or more than 180. All right, so a major arc is more than 180. Now, I want you to notice something between the minor arc and the major arc. When we go to write a minor arc, we just use two letters. When we go to write a major arc, we must use three letters. All right, so minor arc, we use two letters to write it. Major arc, we use three letters to write it. Okay, and we go in the order of the letters. A semicircle is what happens when the circle gets cut in half. So remember, like we said on the last page, if the circle gets cut in half and we are just looking at half of the circle, we know if the whole thing is 360, that half of it has to equal 180. So a semicircle has to equal 180. It's half of the circle. All right, this right here, down here, just restates what we just set up above. Minor arcs, use 2 points to name it. major arcs and semicircles use 3 points to label it. All right, so let's go ahead and look at some examples of this after we talk about one more thing. Adjacent arcs is not that important, but it's arcs of the same circle that intersect at exactly 1 point. We don't really do a lot with adjacent arcs, but this part right here is going to be big. Arc addition. All right, arc addition says that if I have to find a whole arc, and let's say that we had this picture, oops, let me delete that, let's go with a pen. And let's say we had this picture where it connected our radius to those points. And let's say they asked us to find arc AC. So we want to find from A to C. All right. Notice that we would take this first arc, this little piece, the orange piece, plus the yellow piece, and that would tell us the whole entire thing. So the arc addition says every little piece that we pass, we must add it up as we go in order to find the total arc that they're asking us. All right, central angles and arcs are going to be the same measurement. All right, let's look at an example. It says find arc BD. All right, it wants us to find the measure of arc BD. So when I look at this picture, from B to D, if I was doing a minor arc, so it's got to cover half a circle, I must rotate from B to D going this way. Now technically we can rotate any way, but if I were to go B to D the other way, you'll notice I cover more than half a circle. That would have been a major arc. If it's 2 letters, it's a minor arc, so I must go from B to D this way. All right, now what we can do in this is we can find this missing angle for these 2 combined right here, because if you look at this picture, we have a diameter right here that cuts this circle in half. All right, so if I look at the right half of this, this whole half here has to add up to 180. All right, you'll notice they gave us 52 in there. All right, so if I take 180 minus 52, it's going to tell us what's left for our orange piece, which tells us 128. Now, if 128 covers both of these, the arc that covers that in between would go from there to there, which gives me 128 for the arc then. All right, so we found the central angle first, and then whatever that central angle, the arc should match. Now again, you'll notice the 128, if I traced both of those sides, was between these 2 points. So the arc between those 2 pink lines has to be the same as the angle that was on the inside. So our answer for that arc should be 128. Now, when we look at these pictures, we are always going to be trying to look for that semicircle, that half line, so that we can find things that add up to 180, and we can fill in missing angles. All right, so half a circle always has to add up to 180. All right, let's look at this next question. It says find arc LJN. So I'm going to go to my picture and I'm going to trace L to J to N, but I must go through the letter J before I get to N. So notice I would have to rotate from L through J and stop at N. Now, you'll notice in this picture, it tells us that there is an angle of 40 degrees in there, and there is an angle of 25 in there. Well, that means this blue arc, if this angle was 40 here and this angle was 25 in here, if I add those together, I know the blue arc is 65 on the outside. Now remember, it wants us to find the rest of the circle. And right now we know that these two pieces added up to 65. Well, remember, we know the whole circle has to add up to 360. So if we know that the whole thing is 360 and we subtract the part that we know, which was 65, it's going to tell us what's left, which would be 295. So our orange highlighted part, LJ to N, should be a total of 295. So LJN, the arc, it's a major arc, which makes sense, it should be bigger than 180, is a total of 295 degrees. All right, so we're going to use missing pieces, again, half a circle, and try to find the missing part. Now, the second thing we're going to look at today is what happens when a chord meets a radius. All right, so if we have a chord and a radius that intersect, they are going to meet and be perpendicular. All right, remember, perpendicular forms a 90-degree angle. And what we're essentially going to do is we're going to be forming a triangle here. All right, we're going to be forming a triangle here. Now, when we form that triangle, what we're going to be doing to solve it is a squared, the Pythagorean theorem, a squared plus b squared equals c squared. All right, now we're going to use parts of our picture to come up with different bits of info before we solve. All right, so let's look at an example. The question says, find NP. All right, so we have a radius, RM, that is intersected by a chord. Now, you'll notice we're going to form a triangle. And what we're going to do is we're going to focus on this little triangle and do Pythagorean theorem to try to solve for the missing piece. Now you'll notice in that picture I just drew a purple line. And that purple line is a radius. If you look at this picture, RM is technically a radius. It goes from the center to an end. RM has an 8 and a 9 on it, so if I add 8 plus 9, I know that the radius, this purple line I drew, should have been 17. All right, now, after I go ahead and do that, what they want us to do is they want us to find NP, they want us to find the chord. So I'm going to put an X on this piece of the line. Now, we know that the chord gets split because it's bisected, so that would also be my X. In this picture, our focus is going to be on this little triangle right here. We are going to remove that triangle, and we are going to look at the pieces that are on it. I have 8 on the bottom, I have 17 on the left, and I would have had X on the right if I removed that blue triangle from the picture. Well, I'm going to go ahead and do Pythagorean theorem then. And that says 8 squared plus x squared is equal to 17 squared. Remember, C is always across from the 90 degrees. That gives us 64 plus x squared equals 289. I'm going to solve it. I'll subtract 64 over. I'm left with x squared equals 225. I'll square root it, which tells me that x is 15. Now, the question wants us to find NP. So, if I got 15 for x, and I got 15 for my x, then 15 plus 15 will tell me the whole thing for NP, which tells me NP is equal to 30. All right, so when the chord meets the radius, we are going to form a triangle. We are going to use the numbers in the picture to come up with the missing piece, And then after we label the missing piece of our triangle, we're going to do the Pythagorean theorem. All right, let's go ahead and do another. I've got the following picture. It says find QR. All right, I've got a radius that bisects, is perpendicular to a chord. We're going to form a triangle. Remember that red line I just formed is a radius, and if I were to highlight this piece right here, that's a radius. It goes from the center to an end. 10 plus 10 will tell me that my radius should actually be 20. Now we're going to be solving for the chord, so I'm going to go to my picture, and I'm going to highlight in green the triangle that I'm going to be working with. And I'm going to put an X on the missing side of it, and I know that this should be the same because the chord got bisected into two equal parts. Now let's go ahead and remove that triangle and see what we're going to be looking at. I've got a 10 on the bottom of the triangle I removed, I got a 20 on the left, and I have an X on the right. Let's go ahead and do Pythagorean theorem. X squared plus 10 squared is equal to 20 squared. Well, let's turn those to numbers. That's x squared plus 100 is equal to 400. Now let's subtract 100 over. I'm left with x squared equals 300. All right, let's go ahead and square root the 300. And we do that, it tells us that x is 17.3. Now remember, it still wants us to find the whole chord. So if this x was 17.3 and this x was 17.3, then I will go back and I will add 17.3 plus 17.3, and that'll tell me that QR is equal to 34.6. All right, so we're forming a triangle and we're doing the Pythagorean theorem. Use your picture to label the radius that we formed by adding the two numbers that were on the first piece of info from the picture. All right, let's go ahead and we're going to go through three problems. We're not going to focus on number 4 right now. We're not really going to look at anything like 4 yet. So for now, we're not even going to go there. We want to pick up on the habit of what's taking place. All right, so let's go ahead and do 3 examples together. And then we'll go ahead and get into some practice after this. Question says find AH, so they want us to find that chord. Remember, if we have a chord and a radius that meet, we can form a triangle. Now, if I form that triangle, remember, we can find out what that blue radius that I just drew in equals by taking our other radius and adding the two pieces on it. 7 plus 5 tells us 12 for that piece. All right, now let's go ahead and put X on our chord. We're going to put an X on the missing side, so we're going to be solving for that. And we know that it gets split into two of the same, so whatever I get for that X, I'm going to put in the spot of the second X. Now let's highlight the triangle that I'm going to remove. I'm going to remove this green triangle, and I'm going to draw it exactly the way I see it when I remove it. My 90-degree angle was up here. My 5 was on the left, my 12 was here, my X was there. All right, let's set up our Pythagorean theorem. X squared plus 5 squared should be equal to 12 squared. Well, that's x squared plus 25 is equal to 144. Subtract 25 from both sides. I'm left with x squared is equal to 119. Now, remember, to free that up, we want to square root both sides. So when I square root 119 on both sides, I get x to equal 10.9. So we did the Pythagorean theorem to find the missing part of the triangle first. Now remember, after we get our answer, we're going to go back to our picture and we're going to put in those 10.9s. So 10.9 here, 10.9 here. So to find AH, I'm going to take 10.9 plus 10.9. All right, now when we add those together, that's going to give us that AH, that whole chord, equals 21.8 for our final answer. Okay. For number 2, we're going to slightly change the question on you. I want you to make this say find angle, measure of angle AOB. So what we're going to do is we're going to try to find this x that lands right in here by this central angle. So let's look at what they give us. They tell us that arc ACB, so if I trace A to C to B, that arc right there should be 200 is what they told us. It's a major arc, so it should cover more than half a circle. We know that the whole circle should add up to 360, so 360 minus 200 will tell us how much is left on the top of this circle. It tells us that there's 160 left. Well, if this arc from A to B is 160, that means the angle that is formed on the inside between those two lines should be the same as the arc that it points to. So in this, x should equal 160. So technically, the measure of angle AOB should equal 160 degrees. All right, let's go ahead and do one more example. This time they want us to name the arc with a measure of 100 degrees. All right, so name the arc with the measure of 100 degrees. I notice if I'm naming an arc and it's smaller than 180, I should be using 2 letters. All right, so we're going to try to find some missing pieces. I notice in this picture that this line right here cuts it in half. So my 3 angles here, 70, 80, and blank, have to add up to 180 because this covers half of a circle. All right, so if I take 180 minus 70 minus 80, it's going to tell me that this piece right here should have been 30. Now, in this picture, I can go back and look at other parts of this. If I connect this line right here, notice the arc between those two would be half a circle, so these 3 have to add up to 180, 30, 80, and blank. If I take 180 minus 30 minus 80, it's going to tell me that this angle was 70. Now, technically, I could fill in my missing angle on the last piece if I wanted to. If I were to trace this line and cut my circle in half, I know that this half of the circle has to add up to 180. Well, if I have 70 in there, 180 minus 70 tells me this piece was 110. So I can technically fill in all the angles. Now, the picture or the question asked us to find an arc that covers 100. Well, you'll notice I can't skip around, but if I went from here to here and I passed 70 and 30, 70 plus 30 will tell me that I get 100. So I've passed 100 if I pass those 2. An arc that is less than 180 must use 2 letters. So the 2 letters that I started and ended at were A and C. And we're talking about an arc, so I'm going to put a curl above them to symbolize that that's the arc on the outside. So you'll notice angles have been inside, arcs, we put curl above it to show that we're talking about the outside of a circle. You could have wrote that as CA, but you may only use 2 letters because it's a minor arc. All right, so we're going to get into some practice of finding missing arcs or solving for missing chords right now.